Good morning, 7th grade. Today we're starting a new unit on constructions and scale drawings. First, we have to know about angles. Today in particular, the first lesson is on adjacent and vertical angles. I want you to be able to identify what adjacent and vertical angles are, and I want you to be able to construct angles using a protractor. The type of protractor I'm going to be using today looks like this. All right, first off, we have to talk about the different types of angles that we're going to need to know. There are other angles than these, but these are the only ones that you're going to need to know. So first off, we have acute angles. These are ones that are less than 90 degrees. Right angles are ones that are equal to 90 degrees. Obtuse angles are greater than 90 degrees, but less than 180 degrees. And then straight angles are equal to 180. There are things called reflexive angles, I think they're called, and those are greater than 180 degrees but less than 360 degrees, etc. So there are other angles than these four, but these are the four that we need to know. All right, let's see if we can classify these angles. So I made this right here. We have four different types of angles here. Each of these are a type of angle that we learned about before. We have acute, right, obtuse, and straight. Okay, let's start with A. Let's identify what this angle is. Now, in order to use a protractor, we have this center point right here. That center point is where we place the middle point of our angle. And then we either line up with this line there, or we line up with this line over here. And they'll both give us the right answer. But you have to know how to read it. So first things first, I'm going to place the center point right here on the center point. Then I'm going to line up with this bottom line, this line right here, on, let's say, the left one. Making sure it's all straight and lining up perfectly. All right. So you'll notice that there are two rows of numbers here. And that depends on what side of the protractor you are starting from. You'll notice that these numbers start at 180 degrees from the line that you referenced from. Like, this is your starting line. I know it's my starting line because that's the line that I started with this line. These start at 180, and then they go down, all the way down to 0 over on this side. The numbers on the outside start at 0 and go all the way up to 180. Now, when using protractors, your angles always start at 0. So since I'm on this left side, I'm going to be using the numbers on the outside because these numbers are starting at 0. Now I'm measuring the angle from this line to this line. So going on the outside, because that's the numbers that start at 0, I figure out that this angle is 120 degrees. And I see that right there. Lines up perfectly there. So this is 120 degrees. Looking back here, it's not less than 90, it's not equal to 90. It is greater than 90, but less than 180. A is obtuse. All right, let's go on to B. B, we're going to stick the middle point right here, and let's line up the left point exactly on this line. Okay. Now we're going to measure the angle from here all the way over to this side. So starting at 0, again the outside, we count all the way up until we reach the other line, in which case that is at 180 degrees. So this angle is 180 degrees, which, looking over here, equal to 180, this is a straight angle. Straight angle. On to the next one. Number C, or letter C, I should say. I'm going to place the center point here. And what I've done in the past is I've gone and I've lined things up with the left edge. You don't need to. That's just typically what I do. Either one works. So what we're going to do is we're actually going to line up the right line, the right side. Notice I'm making sure that it stays straight on this line right here. It takes a little bit of fine tuning until you get it exactly right. But see, now that I've lined it up on the right side, I can't use the outside numbers anymore because these start at 180. Now I got to go to the inside numbers. This starts at 0. So now I go until I reach the other line. 10, 20, 30, 40, and 4 degrees more than 40. This angle is 44 degrees. So that would make this angle a acute angle. There's only one more. So if you know how to do this one, good on you. All right. I believe that's all lined up. So I'm lining up on the right side, so I'm going to be using the inside numbers, starting at 0, going all the way up to 90. So the angle here is 90 degrees. Now I didn't write the curve here. Typically what you do with all these is you draw the arc, and that lets you know what your angle is that you're measuring. For a right angle, it's a special one, and you've seen it before. It's a straight, it looks like a box in the corner, and that lets people know that it's 90 degrees. So this is a right angle. So these are examples. This is an obtuse, this is a straight, this is acute, and this is right. So let's go ahead and draw an example of each. And I'm going to do this rather quickly. What I'm going to do is for acute, I'll use red. Make a starting point. That's going to be the middle points in all of these angles. Make a starting point. Draw a, line it up with your protractor right in the middle. Come all the way over here to the 0. That's going to be how you started out. Now acute means that you can pick any angle in the first 89.9 degrees. Everything up to 90. So I'm going to pick a random number up to 90. Let's say 62. So I go up to 10, 20, 30, 40, 50, 60. And 2 more than 60. So I go 2 more of these little ticks on the outside. That right there is 62 degrees. Now how do we actually draw this? All I have are dots. Well, this is my starting point. So I'm going to draw a line using the bottom of my protractor because it's straight. I'll go ahead and do that. I can label it as 62 degrees. All right. Obtuse. Make a starting point. Place your protractor on it. And I can either have my starting line coming from over here or starting over here, I'll go ahead and have it starting over here. I know the corner of my protractor is broken, but that's my 0 point right there. Now, in order for this to be obtuse, I have to start here and I have to go all the way past 90 degrees. So I can choose any point along this outside corner over here, because all of these angles are more than 90 degrees. So I'm going to pick a random number. Let's say 174. Right there. Almost looks like a straight line, but it's not quite. So I'm going to draw a line from the first point to the center, and then I'm going to draw another line from the center point to there. See how that's not quite a straight line? Drawing the angle, that's 174 degrees. Okay, another color. This is going to be a right angle. Again, making a starting point. Let's make the starting point right here. And what I have been doing is placing the protractor relatively flat in reference to the bottom of the page, but we don't need to do that. We can actually place it like this, or like this, or any way that you want to. Let's place it like this. Again, making the point all the way here at 0. Now a right angle is equal to 90 degrees, so I go up here to where it says 90. I place a point right there at the end. I draw a straight line to each point from the center. And then I draw that special looking angle measurement thing here, and that is 90 degrees. That is a right angle right there. Even though it's tilted, it's still 90 degrees right there. And then finally, last color, let's go ahead and make this one green. Make a starting point, let's say right here. I typically make my starting points a little bit bigger than my end points, but that's just me. Place it on here. A straight line means you go from 0 all the way to 180. And the straight line will be right like that. So that right there is 180 degrees. Okay, that is how we can construct angles using a protractor. Going on to the back of the page now. I'm going to go over how to identify adjacent and vertical angles. Okay. Adjacent angles share a common side. Share a common side. And then vertical angles those are opposite angles formed by the intersection of two lines. So what does this look like? Well, let's get two lines going here. I'm going to have one line going like this. I'm going to have another line going like this. All right. I'm going to label these as angles 1, 2, 3, and 4. Angles 4 and 1, notice how they share this line with each other. So angles, and this is how we write angle 1 and angle 4 are adjacent. Angles 1 and angle 2 and angle 2 are adjacent. Angles 2 and 3, and then finally angles 3 and 4. These are all adjacent angles because they each share a side. Now, what are the opposite angles? Or not opposite, vertical angles. Vertical angles, those are the ones that are opposite from each other. So angles 1 and 3, and angles 2 and 4. One interesting thing about vertical angles, vertical angles are congruent. And congruent means that they have the same measure. They have the same measure. If I were to find the angles for 2 and 4, I would place this being my center point for all these angles. I would place that right there, line up the 0. This angle right here looks to be about 36 degrees. Because I go up here to 35 and then it's one more. 36, 37, somewhere in there. Now if I were to find the angle of 2, I go out here to 10, 20, 35, and then one more. This is also 36 degrees. Angles 2 and 4 are opposite from each other, and they also are congruent. They are the same. Okay. What I want you to do for homework is I want you to do on page 274, I want you to do numbers 5 through 12. Now when you get towards the end, numbers 8, 9, 10, 11, and 12, they want you to find a value for x. One thing about, last thing. Adjacent angles. I already said they share a common side. All right, that's your homework. Okay, have a good one. Bye. Hey, 7th grade. I wanted to add this thing at the end here because I didn't really go through how to do a couple of these problems at the end. So I'm going to go through a couple of examples. First, one of the ways that we reference angles typically, instead of writing 1, 2, 3, and 4, we'll actually use letters. So if I wanted to talk about this angle right here, this green angle right here, what I would do is I would use the angle symbol, and I would do A, B to E. I would go from point A to point B to point E. Angle ABE. That references this angle right here. If instead I wanted to do the angle, let's say over on this side, this angle in orange would be angle EBC. E to B to C. Now, I think there's probably some convention here when you get into high school, maybe having to be in alphabetical order. But I don't care if you use E to B to C, or if you were to do angle C to B to E. In my mind, those are referencing the same angle. And likewise, this one, instead of being A to B to E, you could have also had E to B to A. It makes no difference to me which way that you do this. E, B, A. So that's how you can reference angles, specific angles, when you are given lines with dots on them. Okay? Another example, and this is for numbers 8 through 12. If we have some angles, let's say this and this. If I know that this angle is, let's say 25 degrees, I'm not sure that it is. I could get a protractor and check it, but let's just say that that is 25 degrees. And I'm asked to find this red angle right here, and they call this angle X. It looks like I don't have enough information. Like, I guess I could get a protractor and do it, but there's a way to actually mathematically tell the angle, the value of this angle here. That's with the understanding of a straight line. Remember, a straight line is 180 degrees. So if I look at this angle and this angle together, these two adjacent angles, I know that angle X plus angle 20, this 25 degree angle, this has to equal 180 degrees. Well, doing a one-step problem, I can take this 25, move it to the other side by subtracting it, and I'll find that my X is equal to 55 degrees. X is equal to 155. That's how we can do this type of problem. And if we had two vertical angles, like this, and I'm showing that this angle right here is equal to 124, and this angle right here, ooh, I should do this in red. This angle right here is 2x. If I want to find the value of x, I have to remember that vertical angles are congruent. They have the same measure. That means that 2x has to equal 124. In order to find what x is, I divide this side by 2, I divide this side by 2, and I find that x is equal to 62 degrees. And that should be degrees up here. X is 62 degrees. So that's this one, these ones. Last one will be a one with a right angle. So I'm going to eyeball this as a right angle. If you measure it, it might be a little bit off, but I'm going to write that. This says that this angle that I just drew is supposed to be 90 degrees. If I draw a line like this out of it, and I say that this is equal to 2x, and this side over here is equal to 3x, well, how do I have enough information at all to do this? Well, you have to realize that this angle right here, which is 2x, and this angle right here, which is 3x, has to add up to the 90-degree angle. So 2x plus 3x is equal to 90, in which case this becomes 5x, which is equal to 90. I divide each side by 5, and I find that x is equal to 9 divided by 5, which is 18. X is equal to 18. So that's enough, I think, to get you started on the problems. Again, let me know if you have any questions. Thanks. Bye.